So I actually had to work a little bit hard to get this issue here. So at this point, the version says, okay, the closure may outlive the current function. It borrows goodbye message, which is owned by the current function, and may outlive the borrowed value. So what I've done here is I've created a command handler that um, is not static, and by static meaning that it will its lifetime does not depend on anything external. Um, and the reason why is I have this goodbye message, which I've defined in the scope of the main function, and I'm using goodbye message inside of here. And because this closure is generated without a move over here, it is going to borrow goodbye message and use it. Now we can actually fix this by changing this to be moved, and we can move it inside there, and now that function or that closure is static because it owns everything that it needs. Um, but doing it this way, now it has a lifetime of here and can no longer be used because our commands or our handlers all need to have static lifetimes. Um, so a little bit of a caveat here. I want to say, well, it's pretty easy, maybe, to make functions be always be static, but they don't have to be. So we're going to add some complexity just to make this work. Well, not complexity. We're going to change that. So this is fairly straightforward, but it's going to look a little confusing. So our commands here, we can introduce a lifetime here and say that the command handlers also need to be bound by that lifetime. Or not bound by it, but really the command is going to be bound by the lifetimes of the command handlers. And so this is going to add a lot of additional lifetime inclusions here, because this is all going to be there. But we're just going to add a few ticks into this, and we should be good. So instead of being static, it's going to be tick A. Same thing for here, and I think that's the last one. Missing a lifetime specifier. Okay. Oh, because your setup, we just allied that one, I believe. Sorry, we do this. Let's just make that. Lifetime may not live long enough because our command handler here is get command. It's going to return this plus tick A. Yeah. Unused. Okay, here's just some unused stuff that I had, and no problems. And we're compiling. And like to the user, it's not that big of a deal. You see the documentation for this is going to introduce this lifetime where, why does that not show the tick A there for the handles? It just didn't update that. That's interesting. Okay. So what did I just do? I kind of blew through that, and let me maybe explain. Um, so the problem that we had is this command is going to take ownership of these command handlers, but the command handlers themselves, even though they may not be references, they have a possible lifetime. Simply because they themselves may refer to data outside of this. And usually lifetimes are used for when you pass in a reference to something, you just want that reference to not outlive the object that's storing that reference. In this case, we're giving it an owned type, a handler, but the handler itself may contain internal references to things that are not static. So in this pattern of owning something that it you don't know what it may need to have ownership of. So rather than levying a static lifetime onto that, you can say, well, let's because we don't need to. There's no reason to levy a static lifetime onto the handlers or whatever it is that you're holding. You just need to properly mitigate that, which basically says if I am the command handler holding the stuff and I am holding children, in this case handlers, that could themselves point to other stuff. Now I have a lifetime relationship, meaning that my command object must live. Well, no, the handlers must live as long as the command object itself. And if it goes the other way, then the compiler will deal with that. It won't deal with it. It'll complain. So how we define that, and I understand this is confusing. We say, okay, command is going to have a lifetime, and lifetime we're calling tick A, and the handles that it's holding must also have a lifetime of that same tick A, or at least of that same tick A, is what this is saying. So what is stored here, actually what is stored in here, must live. Well, we can only hold this for as long as this lives. No, that's not what it says. It says that this will live at least as long as the command does, but it doesn't have to be static. So we carry on the tick A lifetimes as we write the application, because we have to continue to reflect that lifetime trait, or that lifetime trait bound. So here, when we're adding a command, we're saying that when we're going to take ownership of, and actually command result, this is really this, right? Expected path. It doesn't like that from a point of, but the tick A refers to this entire handler. So it's saying that the handler that we're going to give, we're going to own that, but the handler itself must live as long as the command itself, or the handler must live as long as the command. But it doesn't have to be static. because that's what the real lifetime bound is. Same thing for here. This is an easier way to see that. This actually looks like tick A refers to command result, but it doesn't. It refers to the entire trait ahead of it, like this. Okay. So that is what needs to be done in order to allow this sort of thing to be done, where we're referring to something outside. Now, where this would become more more in your face is if we had like a custom handler that it looks like this. And this is going to force us to define some trait bounds on custom handler. And then if we impl command handler for custom handler, missing generics for trait. Oh yeah, because this has to have a W in front of it. W where W, there we go. Oops. All right, execute, good. There we go. Let me reduce the font size to give us some real estate. We need a W here. And yeah, we can elide the lifetime for this because we don't care. Method execute has, this is a W, right? Oh, it's really a mute W, right? There we go. So here's our in-your-face custom handler, which is what's really going on under the hood when we write this sort of thing. So if let me actually just make a new test function, test lifetime struct. We're gonna delete this from here. And here, we're going to pass in a command handler. No, custom handler. Goodbye message is that. Why doesn't it like that? Oh, because we're using the FN version. There we go. And this does pass. So let's look at this because this is like this is very real, where we would have a custom handler that's referring to data by reference, not by ownership. And yeah, we could certainly give it ownership, but we don't need to. And there's any number of reasons why custom handler might hold references to something rather than owned versions. So it has a lifetime here. And actually, to make this to not overuse that, because the tick A in the other version is different than the tick A in here. So this, I'm changing it to tick B. So the lifetime of this struct is dependent, or really the lifetime of goodbye message is dependent on the lifetime of command handler, because we're storing a reference, and this is just using it. And this is not static by any version of that, and yet we can now pass that to add command, because add command has a command handler that's tied to the lifetime of the command itself. So this is the quote right way to do it to get rid of all of your statics. And I believe with this now we no longer have static um, lifetime bounds in our command. Let's just look for that. Well, let's look for tick static, and we don't. So now we don't have any static lifetime bounds. So we can do things like this, even though may seem a bit unnecessary, and we could just get away with it by having static lifetimes. But we can always do it right and then not have to go back and fix it or make concessions in our implementation or our use of this library when we do in fact want to do something like this. Actually, you'd have to allocate everything on the heap and have reference counted things if you wanted to have static lifetimes. But that's a huge pill to swallow, just to get around a command struct that was trying to do things inside of statics. There. So certainly some value added in there. I don't know if this made lifetimes more or less confusing. In a way, I think it's less confusing because I'm not like it's hard to have a clear explanation of what lifetimes are. I mean, certainly the documentation is all right, but you really have to do it several times where you have a problem like this and you deal with the lifetimes yourself. Okay. That is that. Actually, that may not be that. Well, I want to check something. So that's right here. So I want to split this. You ever see two impl blocks of the same thing? This is your bonus content. Where you open the struct multiple times. I want to do that here. So I'm going to do it like this. That's going to break out. That's going to stay in. That's going to stay in. And that's going to stay in. So we're not getting a lot of advantage out of this, but I just want to show you. So run is not dependent on any lifetimes at all. So I'm going to take run. I'm going to delete it. And I am going to impl read and write for command allied lifetimes read and write where, let's just do it ourselves, w io write r io buff read. Open this up, and now we're going to paste in. Crud. Okay. I lost my copied version of the run command, so we're going to go back. Delete that. Let's put that in place here. It's a little bit unnecessary, but it's I'm kind of trying to prove a point here. There we go. So this version compiles and runs fine. Now, what did I do here? I made two different impl blocks for command. There's this one here, and if you scroll down, there's this one here. Now, why did I do this? There's not much benefit in this from like a code generator. The code generated is the same, except I need more coffee. That's not why, but I do need more coffee. I elided the lifetime here, basically signaling that the lifetime of the methods in here, or the methods in here, do not depend on the lifetime constraints that might be part of command. Because I have not introduced a lifetime here, therefore none of the methods that are in here are going to be dependent on that lifetime. Run does not do anything with lifetimes. It just looks at the handlers and runs them. But this one does need the lifetime defined here, because the command is now going to be bound to that lifetime, and all of the functions here that take either as arguments or return values that have the lifetime is going to be bound here. So here's the lifetime, here's a lifetime, and here's a lifetime. So I split that into two impl blocks, mostly to tell my future self and future developers that stuff inside of here is not dependent on lifetimes. Because sometimes you need, well, there's nothing wrong with putting this in there and having an unnecessary requirement on a lifetime. And there's actually almost no benefit of moving this out here, except that you're almost then declaring to somebody that run is not going to be dependent on lifetimes. Even though if you made it dependent on lifetimes, doesn't really matter. It doesn't change it. Why that's beneficial is hard to articulate, but it is. But it's one of those where, like, I wouldn't necessarily like write some sort of design directive that says, "Oh yeah, you must do it this way." But by understanding what your dependencies are, even outside of really anything else, that's the reason why you would declare multiple impl blocks with different bounds that are not just different incarnations of your bound here. And in fact, like, we don't need this bound here. Like, I can delete this and it should still compile fine. I can have it there, but I don't need it. So I would probably delete it. And you'll see, if you're looking at my code, a lot of times when I define a struct with generics, I don't define a trait bound here. And like I said, there are reasons why you could do such a thing and should do such a thing. Okay. I've definitely talked way more on this video than I need to, but this is some tough stuff. And I'm hoping that by talking this out, you've at least heard it several times from different points of view that maybe have given you new understanding. Or maybe it's just more confusion. Not sure. I'm gonna push this up here. Video comments, and it's available in my fork, which should be public if you need it. And actually, just for fun, let's come and look at that fork here, and just take a diff of that. So it's really going to be just my last commit because I only made one commit. So I changed command to have a lifetime, and I took out this unnecessary trait bound. The lifetime is going to be propagated into this. In this case, I have two impl blocks, one that where the lifetime doesn't matter, and that's where I include the run. This is where our diff gets really wonky. The Yeah, so our diff gets wonky here. But we're back here. We've taken out the statics, and we are given it an explicit lifetime bound. It's only going to be bound to the command object itself, not to static. So all statics are replaced with tick A. Same thing here. The command handler is now tick A. Just lifetime propagation. Here's the other. Oh, this is our set of tests that we wrote to be able to exercise a possible use case of the language that, or of the library that would run afoul to the static lifetimes that were generated before that now work just fine with an explicitly bound lifetime. That's it. Okay, I'm going to shut up and post the video.